Sure. So we have learned about that multiple exception handling. At a time, we can handle multiple exceptions and we can decide. Means if there are more than one exception, for more than one exception, we have something the same, we can go for this kind of concept. Next, there is one more thing called as exception groups. This is something very interesting. It was like a recent invention. So 06 exception and okay, grouping. You understood what is this multiple exception handling, but exception grouping is slightly different. Say initially, to understand how this works, in case one, so it was introduced in the very new version, which is 3.11. If you see here, what is the Python version I am using? Python 3.10. So there is some issue, so we cannot get the latest container. So but like if you can get a better image, we can test these things. So what is this feature saying is like, till now, okay, before going there, I want to explain one more concept about the raising an exception. So as I'm telling about this concept, let's continue this. After that, I will tell what is this raising of an exception. So means we can raise an exception. Means till now what we know is like, whenever we do some operation, we are getting exception. But if you do the raise, we can even raise an exception. Sir, why you want to create an exception? Why do you want to break the code? No one generally want to break the code, but just imagine like this. Let's say you are playing on a racing game, which is like interactive, multiple players are playing. Suddenly what happens? One of the person's internet was down. It is slow enough. So when the internet is slow enough, you don't want to give the player to play because others will also be affected, right? In that case, you want to stop them. So I'm trying to say is that there will be some use cases where you want to stop the things. So in those cases, we can raise an exception. Okay. In this particular scenario, see here, I'm raising a value error directly without anything. So value error, if I raise, it will handle that and it will be working. Now, let me see this one. As you know, it is like a older, latest Python 3.10. I don't think these features will work, but still I will give it a try. Check whether it works or not. So clear, and everything will be backward compatible, not future compatible, right? So as of now, it's an ordinary exception. It is working. So when this exception is coming, it is handling it. Did you see? We gave it. Now coming to the second case, what we need to do is something called as exception group. Did you see it is throwing an error saying that you don't know what is that? Because it is a newer version. So exception group is not defined the same. So the point is like exception group means we can have multiple exceptions. So till now in the previous case, what we learned, when you're doing this operation within the try block, if you get any of the exceptions, you can handle. But for all these three exceptions, if you want common logic in terms of handling, you handle it. But what if when you're performing, you will get like multiple exceptions? You want to handle all of them. So that's where exception groups comes. So exception group can't be handled by individual exception type. We need to have multiple things. If you see in this particular thing, it is raising two exceptions, value error and key error. Sorry, type error. Now we need to have exception handling for both the things. And both the statements will execute. That is something very interesting. If you don't handle one of them, then it will throw an error. Anyhow, as a safe side, we have umbrella exception. But if you don't have that, it will throw an error. So that is what about the exception groups concept. So in the exception groups, there were like multiple variants, just to tell you. So in the third case, if you see, so in this case also, we have it. But the difference you see here, generally till now, this concept of except, right? So exception handle can't handle like individual exception types. When you have the group, so if you want to handle them, we need to write like this. This kind of syntax is something new in Python 3.11. So what it actually says like, so both except star and except can't be used within the same try except block. Means if you want to make place all the things like except group or individually like an except, but don't make like combination. So like that. And the next one is like if you have added like a new exception now. So OS error. So you handle like value error, type error, and the other one is exception handling. So when this OS error was not handled individually, it will handle like that. So if you have like Python 3.11 version, just give it a try. It's a very interesting concept. So next thing in terms of the exceptions is the assertions. So assertions are something very interesting. Whenever we are working on the exceptions, say like 07 assertions. Assertion is one kind of exception, but it is basically used whenever we are working in unit testing. So whenever you want to test a code, whether it is correct or not, there are different ways. Next, you will learn about something called as unit testing and integration testing. But fine, simply thing is like assert is like a statement, which will give like a condition and you give an exception message. So in which case we need to use it? Let's say you are doing some operation, you want to check what is the result. So whether two values are coming correctly or not. Then what you do generally, you write an equal to till now. So what if you have like a big statement? Every time you cannot check, right, whether both are all are equal in the output. It's very difficult. If you see in this case, Python 07 assertions, you can notice that 10 plus 2 is equal to 12. And you are asking, is 10 plus 2 equivalent to 12? And it says yes. And in fact, we have something called as f-string assignments, you remember? So this makes it much more interesting. F-string assignment means the same statement will come and the result will come, whether it is true or false. So fine. So you got it. But we cannot see every time in the console whether it is true or false. So, and also one more thing is like sometimes the programs will not be run by manually every time. It will be run by the systems. So they cannot check like whether it is true every time. So for that, we have something called as assertions. Because if you write like an if condition or else condition, that is fine, but you cannot see that. So the best part for doing this is like using the asserts. Next, when you go for like PyTest, you will learn the same things only. Assert is a keyword in Python. You give one statement, whether it is equal to or condition or any relation or anything. If that is not true, then it will throw exception with this message. In this case, 2 plus 10 is equal to 12 and 10 plus 2, both are equal to 12 only. So nothing will happen. At least these will print. This will not print anything. So ultimately printouts are only for human beings, right? So what if I give like one more assertion? This time I wrote assert 12 plus 10 is equal to 12. This is wrong. But if you run right now, it is throwing an exception. Now, when the things are good, it will be silent. But whenever there is an issue, then it will break the code. So now you understood what is the purpose of assertion. Similarly, assertions are also can be handled. There is one kind of custom assertion type called as assertion error. Whenever the assertions are wrong, this will be happening. So whenever you need not write all these things. For that only frameworks are there called as PyTest and others. But generally you can write at the low level like this also. This is one kind of things. Next, coming to the case of like raising an exception, as I told earlier, and I'm telling again. So the point of going for raising an exception is that 08, I just told like, we can use the keyword called as raise for raising an exception. If I use raise, if I clear and Python, so 08. Did you see that you got a runtime, no active exception to re-raise? means you told to raise, means it is giving a, what is that? For the first time you're seeing something called as runtime error. In this one chapter, I showed you like different kinds of exceptions. So, but this is not the correct way of raising an exception. Whenever you want to raise an exception, you will do like a raise, and after that you give like an exception, right? So, except if I say, it is saying like I am raising an exception. It will not tell anything, just it will raise an exception. So similarly, so this exception is you can imagine it like a class. It is like an instance. You will understand it afterwards, but this is how it works. So this point. So what is this exception class means? Like when you are raising an exception, we need to give some kind of error, right? What is this exception about and why you are raising it? So for that, we can give like this. You can raise an exception and we can give a message. Now, if you see when the code is getting broken, you get the same exception and the message that you give. So whatever the exception we give and whatever the message we give, both were coming. And it is not just like the exception, which is the umbrella exception. We can raise individual exceptions. Now, in this case, if you see, you will get like value error. So instead of others, you get like a value error. Or like if I want to raise something else, say like I can give a type error. If I execute, I get the type error. So purely type error I got. Now, similarly, if I go for something like a name error, so this time instead of just raising, I can give the error type, exception type, and a message. Now, if you see, when you're getting the exception raised, you got the same thing. And so not only this, let's say you have this exception. This time, not just like raising, if you want to handle this, how do you do? If you raise an exception, we need to handle correspondingly. You can handle, corresponding with like say name error itself. So if it is a name error as name any, and you want to handle it, so it's a name error, you get it. So generally don't prefer to use the umbrella exception because so you don't know what else reason could be. You think like it is because of one issue, but something else may happen. So most of the time for the developers, it is possible. And also there is one more interesting point. So there is some code like, if you have an exception and you want to raise an exception, you want to add some content to it. So generally what happens is like, you have this exception, you want to handle it, right? So when you print that exception, what happened? You are getting this message. That is clear. But what if along with your exception, you want to add some more content to it? Means, so this is again a new feature in 3.10 or 11. Let me check it. Till now, what happens? Whatever the exception message is coming, the same thing is coming, right? You remember in the previous cases also I showed, whenever you know the exception is because of a custom reason, you can just give that reason. And apart from that, you can print your message. So if you do that, it is explicitly printing. So it is not going to the exception like this. So whereas what they did like, they made like a new invention. So for this any, which is the exception object, there is something called as add nodes actually. Add node we can do. Of course, this also works in only Python 3.11. So I don't think it will work. So even here, did you see don't have an attribute? Generally, for any object, if you know whether it is an attribute or not, after an object, you give a dot. Most of the time, you get the suggestions there itself. So if you see args is there, name is there, with trace is there, but add note is not there. So whenever you have some kind of container which works in Python 3.11, you can give it a try. So basically how it actually works means, I don't have an environment to show, but what exactly does is that it will raise an exception. Same like your code, it will raise an exception. But so when you do like a except, generally exception should not come. The code should not break. But when you do like an add note, it will add to the exception And then further, if you do a raise, then it will have this exception message and this message together. So if in this case, what I'm trying to do is like, I'm trying to handle that exception, which is second time I'm raising. Generally raise we use only in the try block, right? If you use in the except block or something else, we need to handle it with one more exception. Did you see here? Exception handled in another exception, try another blocks. This is a different type of working. So similarly, if you see, sometimes exceptions can also be raised in this kind of scenarios. You remember in the previous case I showed you, when you do like a division, we should ensure that the denominator should be non-zero. So instead of user validating and computing and then we getting an exception and handling, we ourselves can raise an exception. Did you see, if the denominator is equal to 0, you are raising an exception. So like that, there will be some use cases where we as an individual want to raise an exception. So this is all about it. And the last point before going further into the next chapter is into the tracebacks. Okay, sir, we got an exception. Then how to do the traceback? Traceback means what? So there is one module called as a traceback and the exception. So with that, we can do something interesting. I'll show you. Say like, I have defined some variables. I will use two modules called as sys and traceback. I will show you what is that. Say I defined some variables. Some are integers, some are like one is string and remaining are integers. All are integers. Now, if I do some kind of operations, so within the try block, I can do something. Say first I create like a try block. Within that, I do my execution. And then I write the except block. Within the except block, I will do the handling of the exception. So I will handle the exception. This is clear. So now what happens? I want to execute this code. Clear. And Python 09 so and so. And Python 09. Okay. Did you see what happened? When you did like a number 1 divided by number 2, so minus number 3. So some operation is happening, it is working. So when everything is good, you want to print the output. So, and once everything was done, you want to do it. Say print of f of, so what is this expression? 1 is equal to. And you know the concept of finally, which is not mandatory. Hope you know that try and except are the mandatory and else and finally were not mandatory. Those were optional. And you already know that any block can be written in the finally or in the next statement. It makes no difference. Anyway, both will execute it in the end in the same order only. But if you write in finally, it will be more like a single block. So it's like a cleanup action. So whenever you do something, cleanup is also nearby, then you can be pretty sure, right? That's it. So in these particular scenarios, it makes no sense. But did you see both statements are executing same way? But you are seeing the output as there is no problem. Now let me introduce one more thing. If this time I'm adding like one more expression, so called as expression 2 equal to number 2 multiply by number 4 something. Now if you see in this case, you got it broken. The code was broken, it got to the exception. That's the reason it's not printing the values anymore, right? So fine. So now you understood that there is a problem, but you don't know where exactly the problem is coming. Of course, it's a small program. It's easy for you to understand where the problem is. But how can I know in the programming that where the problem is occurring? So for doing that, there is something called a sys module. Hope you remember from sys we did multiple things, sys.exit and others. So we can do something like this. When you're doing an exception handling, sys.execution exception info. Okay. That exception information, if you want, you were asking. Did you see that it is a tuple of values? Tuple means more than one value in one kind of data type. Did you see what happened? So it is giving like multiple values. Hope you remember, I told you that whenever something is giving more than one value, we can assign to correspondingly. In this case, it is giving like three values: that error message, and the traceback object. So instead of one, I can assign to three values. If you observe, I assign to three values. So this concept is called as unpacking or tuple unpacking, which is common across other languages also. If I execute now, it is assigning to three variables. Now for these three variables, we need to understand what is this doing, right? Within these three variables, we can do a lot of things. Any variable, if you don't know what to do, first thing is like we can ask what is the type of that particular thing, exe type, and also we can ask dir of that exe type. For any object, if you don't know what to do, you can check what is the data type and these things. When you ask it is of type, so it's an object and it has these attributes. So you see it has an arguments with traceback and others. So I understood like this and I did all the attributes for your information. So for the exception type, it is good. For the exception value like this. Similarly for the traceback, which is the object, it has all this information. If you ask like traceback dot line number, last execution, next frame, and all these things, it will tell. It is telling that the problem is at line 17. Did you see that? It is exactly showing you where the problem is. So where exactly? So last index. So means in the 64th position or something. So like that, the frame information also it is giving. We can do furthermore grilling also, but it's okay. In the same fashion, there is another way to deal with this kind of things. There is one more thing called a traceback module. With that also we can get. With traceback, if you want to work, so we need to work with this std out. So means like generally tracebacks will not be written to the output console. Output console is only for the development and learning. Generally, we need to write to a file only, like a log file or something. So that file, if I say like std.out, it will come in the output. Or if I give like a file handler, it will go to the file. So traceback.execute information, if you give, so that's it. So it will take that information and print it. So don't you think that this is what is happening when you run a system? Means like if you run the same code outside without all these things, so don't you think it will do the same thing? If I should execute the same thing outside, Python 09 so and so, don't you think your code is getting broken like this only? Right? The type error and others. And don't you think that here also it is doing the same thing? So the traceback and other information, right? So means the code, how it is broken, if you want to know the exact things, so we need to go in this way. Hope it's clear. What is the difference between traceback and this one? So these are like two ways in which you can understand the line exactly where it happened. So then subsequently, the last point that I want to highlight is about the custom exceptions. Generally, you might have thought like, should we use only these exceptions? No. In real time, it is not a recommendation also to work on the all basic exceptions. It's better to create your own exception. So basically in Python, if you want to create a class, this is how you create my class and you write some statements. I will tell when you go to the classes, but in the same fashion, if you want to create an exception class, this is how you do. Means exception is like a built-in object that you inherit it. I will tell you what is this concept of inheritances and all these things afterwards. But for time being, you can think like this is how you create an exception. If I say I want to create an input error exception, I wrote like that, and this is something called as a constructor. So similarly, one more exception. Like that, anything you need to define a class. As we don't know how to create a classes at this moment, we can park it for a moment so we can see it afterwards. So the next thing that we can see after the exceptions. If you remember in the first time when I'm saying about exceptions, I told that there are two things. One is syntax errors. So this cannot be, you cannot place a try exception to handle the syntax errors. Those should be immediately addressed. Second type, exception errors. I told you that because of the logic, due to some issues, you will get some errors that we need to handle. Means type error doesn't mean every time it is because of the type or every time because of like you are adding or multiplying integer and string. So it can occur different ways, right? Now you understood. And the next one is logical errors. So in logical errors means you are trying to add two values. So it is doing like multiplication. So instead of plus operator, you did a multiplication operator. If you do a mistake like this, how will the Python identify it? It cannot do. So we need to do identify why it is so. So for doing those things, the concept is called as debugging. Like every language supports some kind of debugging. So to work, even Python also supports. So debugging. So the concept of debugging, if I say, there are like multiple ways of debugging. So debugging can be done with a simple print statements. Every language supports this kind of scenario where you can write a print statement to check whether it is correct or not like that. But the problem is that how many prints you will write. So every time you want to check the variable and the data type, you need to write a print again, and again you need to rerun. Again you need to write a print, and again you need to rerun, right? So that is not possible. Sometimes production code will be there when you're debugging, or like sometimes the code will be very large. It will take a lot of time, 5 minutes for executing till that position. Every time if you write a new print statement and again rerun, it will take a lot of time, right? So for that to be more interactiveness, there are two kinds of modules. So one is console-based debugging. So console-based debugging means there is something called as PDB. So later on in the versions, they created a new built-in function called as breakpoint to work on the same. Similarly, like IPython, there is something called as IPDB. There is one more module called as the PUDB. Not that much popular, but it is also there. Similarly, if you go with like a IDE, like a PyCharm or IntelliJ, so you have built-in integration with something called as PyDevD. As we are not going with an IDE right now, I will ignore that. But if you have a PyCharm or IntelliJ, you can just give a try. You will understand that. Not only that, any IDE if you have. Now I will try to see this once. Okay. If you do like a console-based PDB, so you have a lot of options also, like which one to use at what short and others. I will tell you shortly right now. So first, in the debugging concept, so if I try to use the first way called as PDB, so let me try the PDB and to understand how it is. PDB is like a Python module. So PDB is like a Python module. If I say like import PDB, so if I say like, if you want to know how to use that particular module, you can write like help of PDB. So you can understand what all things we can do. If I go one level up, 05 debugging, so clear and Python, so and so. Did you see that what it is doing? PDB is a module. It has, this is the difference. So this is how you do. If you want to run a statement, you can run like this. Or if you want to do like a post-mortem, this is how we need to do. So there are different things that we can do. So you got the help. And after that, if you understood what you want, you can do a queue, so it will stop. And with PDB, what are the list of attributes to see? DAR of PDB. You can see that what all things it is supporting. So primarily it is having even sys module also. So why PDB is having sys module means other modules also will inherit these modules. In future, you will learn that if you do like a control and click on that module, you will go to the documentation of that. So PDB is a Python file only, in fact. So this is all the doc strings, you see. And for implementing, they have used these many modules. So that is the reason you are seeing those modules names also. So means not everything you need not work. So that is what you need to understand down the line. Okay, coming to the usage of it. Let's say I have two variables like number 1 and number 2. So I need to work on them. I have taken two runtime values and converting to integer, and now I want to calculate. So now if I want to do like a multiplication, so I am trying to do the multiplication and get the result. So I said like, result equal to so and so, and I'm printing the result value, which is a multiplication. So if I do like this, how do I know? So if I rerun the same program, it is asking values and 12. So 10 into 12 means like 120 you should get, but I'm getting 22. How do I know? If I write like a print statements, every time I need to write a print of like value 1 and value 2. And if you want to know the type of it also, we need to write. So all these things we need to write individually if you are using a print statements. So rather, if you don't use a print statement, I told, right? For demoing, I'm showing a small example, but in reality, things will be very big. So then what is the purpose of using PDB means like, instead of just like a print statements. So if you use like a print statement, what will happen when you execute? So you get like 10, 12, you got the same values, right? It is printing. But again, you thought like, which is value what? You can write like, so in quotes, value 1 is equal to and a value 1. So and value 2 is equal to value 2, like that you can write. Then again, you give the values, it will try to print. So again and again, you cannot change the things. So for that, so we need to use something called as PDB. Generally, PDB, like unlike other modules, we don't use in the script because in production, you don't want the debugging code to go. So what we do is like generally PDB and like, PDB dot set trace. If I write like these two statements, so they will do like this. You do like 10, you do like 12. Did you see the code is not completed? What it is saying, the next line to execute is line 18. So did you see it has done? And what is line 17? It's a comment. So ignored. So line 18 is the next line to execute, it is saying. So what to do now? You don't know what is the help. You write like H to understand the help. H will give the list of all the helps that you can do. And if you want to list the files, so here it is saying like, for all, a one small character and C. CL means clear, C means continue, so B means break, so L means list, like that we have options. If I say L, did you see it is showing like, so 5 lines around before and after. And also it is showing you the arrow to which where it is present. So now if I do like a N means like next line. So now the execution is that next line to execute is 19. If I say L again, did you observe earlier it is at 18, now it is at 19. Sir, why I'm doing this kind of horrible way? Why can't I do interactive ways by place a breakpoint and do? This is possible, but whenever you're going for a Linux mission, you don't have that UI and others, right? So this is the only way you do, even when you are working on production or like containers. So this is the only way. So now I understood that I will do like a result. I understood the result is 22. I will ask, hey, what is the value 1? I need not before tell what I want. I need not run 10 times. Like in interactive mode, I can ask, I want to check the type of value 1. You see, I got it. So then I understood that, instead of a plus operation, I gave. So I understood where the problem is. So I can do a Q. So it will quit it. So instead of this operation, now I can replace like this and replace it with a multiplication. Now again, I can run the same program. If I give 10, if I give 12, so I passed again. If you say L, it is giving. Or there is one more option called as LL. LL will give the entire thing. So like this, but both will show the arrow. So now if you do like a N means the next line. N means the next line. If you understood, yes, it is correct. Understood. Similarly, there is one more option called as continue. If you execute it, so if you say 10 and at 12, so execution is at line 18. If I say N, it will go one line and then go to the 19. N again one line. But if you say C or continue, so then it will complete the remaining lines without stop. So, but generally what they do is like, when are they using PDB, so they will use something called a semicolon operator. Hope you remember, like statement separator. So most of the time, if you see anyone's code, so it will be like this. So will it make any difference? No, it is just telling that there are two statements. If I say 10, 12, everything is same. If I say like continue, I can do like a small just see or continue. It will work in the same way. Such that in future, after work is done, they can just do a comment. So because when you're committing to the production, you don't want the debugger, right? In the same fashion, so in the next versions of Python, they introduced one function for the same. Means the same code we can use, but instead of this one, so they created this called as a breakpoint. They created something called as a breakpoint, which is same like this code. Whatever the code we have, I can copy and paste the same code we have here. So the point here is that, yeah. So instead of this pdb.help, we can just replace it with a breakpoint. Means instead of this writing 2 lines every time, so people can use it. This came from Python 3.6 onwards. You can just re-execute. Instead of the A, you can go for the B. So and so. It will execute. Exactly. So Python B so and so. Did you see? 10, 12, same statements. L is list. LL, same next. Next. So or like continue. Everything works. They introduced one function just to make your life easy. Similarly, there is one more thing called as IPDB. The same thing again. So but like slight difference. If you see IPDB, it will be exactly the same, but there is one more module for doing the same thing. So if you want to work with IPDB, which is a third-party module, which is not coming like built-in. So whenever you want to use the third-party module, we need to install it. For installing, we use the pip install. So what here I'm trying to say is that, hey, pip install this module if it is not present. If it is present, then update it and install only for the current user, like that I'm giving. It said I have installed successfully. Now, so by default, if I want to execute this code, let me copy paste the same code exactly into this new one. So now instead of breakpoint, I can do like a IPDB. So means like I can do like a IPDB dot set trace. So same like PDB, I'm writing like IPDB. So if I execute now, so clear, so Python, so C so and so. Did you see 10, 12? But this time the UI is slightly better. If I do like a help, it is better. If I do list, colors are different. So it is more interactive.